Let's take the second connection. No problem. Yeah. So yesterday class, we discussed SR latch using NAND gate and also NOR gate. I gave it name active low, active high. Okay. And also then we discuss SR flip-flop. It's a truth table, characteristic table, excitation table. TT means a truth table, characteristic table, and also excitation table. These two parts are done. Then last conclusion of the yesterday class is SR flip-flop is having one disadvantage. What is the disadvantage I told? Yes, invalid state. When both the inputs are 1, it is giving invalid state. We can overcome by using another friend JK flip-flop. So now let's move to the JK flip-flop. So let me start. So in the JK flip-flop, how to make the JK flip-flop? Let's see here. So originally, what is the figure? Let me draw the figure. JK का कुछ full form नहीं. Right, Aditya is correct. It's not like set and reset. Aditya, who is this Jack and Kilby? No. Why sorry, yeah? It should be funny. I don't mind about it. Means Aditya took biryani, right? Okay, so let's do this question. So this is my JK flip-flop. Okay, so this is the original circuit of the JK flip-flop. But let me analyze this circuit easily without doing this much. Okay, how to analyze this easily is you have a 3-input NAND gate. 3-input NAND gate can be equivalent to AND gate followed by NAND gate. You accept it or not? 3-input NAND is equal to AND followed by NAND. Yes, we know it already. So by using that concept, you can replace this 3-input NAND gate with one AND gate followed by another NAND gate. Similarly, here also, you can replace the bottom 3-input NAND gate with one AND gate followed by NAND gate. So just give those inputs. So this is outside input. Next one is name is J. This is having clock. Okay, so let's make it common. So here you join both of them. This will give you clock and K. Okay, just the same figure or not. This only this part is changed. Okay. But yet you are not saying okay, right? Okay. So after this, you have this NAND gate and okay. So you observe here one important point. Both are same figures only. What is the important observation you must have is if you take one rectangle here, that's, what is this one? From yesterday's discussion, what is this one? It is a like just like a SR flip flop. This box part is just like a SR flip flop. So let me explain easily with the help of next figure. I'll come back to that slide again, don't worry. One more time. This is S R Q Q bar. Flip-flop can be made. Yes, it is using NAND, but flip-flop is made with anything. Its operation is same, as we know it already from yesterday class. Okay, now see here for this SR flip-flop, extra two gates are added. What are their names? Externally, two gates are added. J and K. So this is J, K, and here you have okay. So this will give you JK flip-flops figure. So this figure can be simply replaced by this to make your analysis easy. Is it okay? To make your analysis easy, you can replace that particular figure like that. So let's do the analysis. Just 1 minute. Let me take this pic so that I can use it in the next slides easily. Okay. So let's start your analysis. Simply listen here. Okay, right. So let's start the analysis. Firstly, suppose if, let me make the truth table at the end. Your inputs are J, clock, J, and K, and also Qn plus 1. When clock is 0, these things can be anything. Clock 1, okay, if it is 0, 0, 0, 1, 1, 0, 1, 1. Different cases we analyze one by one. Okay, so please listen here. Firstly, let me start the analysis when clock is 0. You tell me the answer. If clock is 0 here, this is a SR flip-flop, na? If clock is 0, your J can be anything, K can be anything. What is the output you will be getting? Please comment from the yesterday class. Yesterday class, right? Very good. When clock is 0, not 1 1 here, when clock is 0, it will be no change. You should remember yesterday I told you already. When clock is 0, whatever may be your input, it is no change. So when clock 1, what happens? Let's do the analysis. See here. When clock is 1, if J is equal to 0, K equal to 0, what is your output? You know, 0 into anything is 0. 0 into anything is 0. So it is a SR flip-flop. You should remember SR flip-flop truth table for your lifetime. Okay. SR flip-flop with the input 0, 0. What is the condition you get? Qn plus 1 equal to Qn. No change. Okay. So wait. Yes. But जिंदगी बर्बाद नहीं. Oh. Is that Rahul? See, please listen, Rahul. It is not latch, it is flip flop. Okay. Whether if it is a flip flop, you see clock is there, it is a flip flop. Whether it is made with NAND gate or NOR gate doesn't matter. Flip flop is flip flop only. Okay. Very good. So now please listen here. When clock is equal to 1, let's start J equal to 0, K equal to 1 analysis. J equal to 0, K equal to 1. For example, if J equal to 0, K equal to 1, clock equal to 1. Initially, you take anything, your wish. Initially, here I am taking 0, 1. Here I am taking initially 1, 0. Both the cases we should analyze now. What is this? Initial value. Now this 1 will come here. This 0 will come here. Just wait. This 0 will come here. This 1 will come here. Now tell me, what is the AND gate output? First, one by one. What is the AND gate output? 1 into 0. What is the answer? 1 into 0? 0. 1 into 0? 0. If both are 0, 0, no change, na? So 0 will become again 0. 1 will become 1. Wait. In this case, what happens? 0 into 0? 1 into 1? 1. So SR flip-flop is there with the input 0, 1. Output will be equal to 0. What is the meaning of this? If you analyze like this, you may say only same as the previous, sir. No. Here if you analyze, you may say it is previous bar. No. For both of them, it is equal to 0 and 1. That is the meaning. It is equal to, what is the meaning here? In both the cases, don't analyze one case and justify. You should analyze for both the cases. You can say it is equal to reset. Okay. Previous state is Qn. Okay. What is the problem here, Sushil? In both the, whether previous is 0 or 1, compulsory in the next state what you are getting is 0. Na? That's why we call it as a reset. So Qn plus 1 is equal to, okay, fine, 0. So this is your answer. For the JK flip-flop, when J is equal to 0, K equal to 0. This is the inputs you have applied. Kumari, please check it. Any doubt, tell me. What is your doubt? Don't see the whole figure at a time. You apply J equal to 0, K equal to 1. You should remember SR flip-flop. You should remember SR flip-flop truth table like anything. Reset means when output is becoming 0, na? In any case, you are getting output 0. When output is becoming 0, we call it as reset. Okay? When output becomes 1, we call it as a set. Is it clear? You should remember SR flip-flop truth table, compulsory. When you apply here 0, 0, SR flip-flop will give you same as previous. When you apply here 0, 1, you get 0, 1. In both the cases, you are getting output same as 0. So let's do it again. I mean for 1, 0. Okay, listen. Here, I want to analyze already initial existing values can be anything. So I assume here initial values are 0, 1 or 1, 0. They can be anything. Your analysis should be true. Okay. So this 0 comes here, this 1 comes here. Because of this feedback, 0 and 1 comes here. Now listen, what I want to do, apply J equal to 1, K equal to 0. Apply J equal to 1, K equal to 0. See, we are analyzing in the easiest possible way, but compulsory you should remember SR flip-flop truth table. You apply 1 into 1, what is the answer? 0 into 0. So 1, 0, what is the output? For SR flip-flop, if you apply 1, 0, you get 1, 0. Here 0 into 1, 0. Here 0 into 1, 0. For 0, 0, what is the output of the SR flip-flop? For 0, 0, it is no change. No change means 1 will become 1 only, 0 will be staying at 0. So in any case, both the cases, what is your final answer you can say? Yes, it is same as 1 minute. Why it is not writing? Okay, fine. So you can say it is equal to set condition. Qn plus 1 equal to 1. Last case we should analyze. Okay, last case we need analysis. Yes, Deep, I understood. Yes, set my output is 1 only. What is your problem, Rohit? Lastly, this is the important case here. J equal to 1, K equal to 1 condition. Some people may not be able to understand earlier. Now you will not face any difficulty. Just listen. You assume initially 0, 1, 1, 0. Two cases I am assuming. This 1 will, this 0 will come here. This 1 will come here. This 0 will come here. This 1 will come here. Now what I am doing is I am applying J equal to 1, K equal to 1. You tell me 1 into 1 how much? 1 into 0, 0. Similarly, here also you apply J equal to 1, K equal to 1. 1 into 0 is 0, 1 into 1 is 1. So now you apply 1, 0. 1, 0 is applied, you get 1, 0. So 0 will become 1, 1 will become 0. If you apply 0, 1 to the SR flip-flop, if you apply 0, 1 to the SR flip-flop, you will get 0. What does it mean? First case it is 1, 0, second case it is 0, 1. So it is not having same answer in both the cases. What is the observation is? It is complement of previous value. Previously 0 it is becoming 1, previously 1 it is becoming 0. It is complement of previous case. So we call this as Qn plus 1 is complement of previous. So technical name for this is toggle. Everybody now easily able to understand or not JK flip-flop working? Yes, you can analyze, nothing wrong. I told the analysis process now you will be getting the same thing. Okay. But here 0, 0 may you will get no change condition. We are saying, okay, toggling. Okay, toggle means what? Switch toggle switch है ना ऊपर नीचे हो जाएगा same. Toggle means 0, 1, 0, 1 हो जाएगा. उल्टा oscillate. हाँ. Okay, fine. So when I am saying the truth table condition when you are having invalid output only. Okay. Sorry, when you are having valid output. What is the disadvantage here, Nishita? It is toggling. It is advantage now. Instead of getting invalid state, you observe. If you apply 1, 1, now you are not getting invalid state. Now you are getting valid state only. It is stable. Okay. It is changing from 0 to 1. Okay. Whether it is stable or not, we come to that. Firstly, you are saying you are able to achieve what we call invalid to valid. You are able to come to invalid to valid or not. How to make it stable is our job. We will do that. So you are able to overcome. We are able to overcome. It is not stable. If it, yes, it is stable. Like yesterday, I told one example now for you. Is that Abhinit? You can do charging with the help of a laptop or one charger you purchase. Which one is same way? If you want, you can use it to make an stable, but it is not stable. Yes, Asif. If it is something initially, if it is something, it will not. If it initially it is invalid case, it is already invalid. I am saying if it is a valid case, then you give 1, 1, it will give you another valid case only. Okay. Or you can give 0, 1 here to make the output valid. Then you can apply 1, 1. What is the problem? Okay. Here, as long as your clock is present, it will change, Amitabh. Okay. That's what I'm saying, Ganguly and all people. First, understand one point. What is that one point? It is not a invalid. That point everybody accepted or not? So you are able to overcome that disadvantage. You are able to come out of COVID. Whether you get some side effects or not, we will see. Side effect is there, sir. How to do that side effect remedy? Firstly, you came out of this problem. You should appreciate that. So you came out of the COVID, but you are getting some cough. You are saying that no, it is not good. Okay, right. Rohit, please you analyze yourself. Okay, if initially invalid, you just apply JK here and check what happens. What is there here? If initially you have invalid 1 1, you apply here 0 1. What happens? 0 into 1, 0 will come. 1 into 1, 1 will come. 0 1. SR flip flop will immediately give you 0 1. Only for 1 1 case, if it is invalid, it may give you invalid again. Okay, don't worry about the invalid. Start with the valid case. In the previous SR flip flop, even you have valid, if you give 1 1, it is not working now, but now it is working. Whether it is toggling, okay, no problem. How to avoid that? It may be advantage for me. This toggle may be advantage. Yes or no? So we should know how to use it. Maybe later we use only this toggling mode as an advantage. Okay, so let's move further. Okay, so please listen here. When clock is applied, 0 0 is already we done, no change, set, reset, set. Up to this, it is same as SR flip flop. But extra is what? 1 1 is not invalid, it is previous bar. What is the name of it? Toggle. If it is already 0 1, it will become 1 0. If it is already 1 0, it will become 0 1. Is it clear what I am saying up to this? Whether it is advantage or disadvantage, just wait for some time. We can use it in so many applications. This is advantages for us. Should not wait for some time. So many cases we use this toggling mode only. Let's go to the next step. Next. Listen. For any flip flop, what I told, 3 conditions are to be calculated. What are they? Characteristic table, characteristic equation, excitation table. Let's make that. J, K, and Qn, present inputs and present state. What is the next state? That is what we call characteristic table. So here you take all zeros to all ones. Okay, I already told you one thing. For 0, 0, what is your output? No change. For 0, 1, it is 0. For 1, 0, it is 1. For 1, 1. For 1, 1, it is previous bar. Okay, you just use that and write here answer. Previous value is 0, 1. Here it is 0. Here it is 1, irrespective of previous value. Here it is previous bar. Previously 0, you get 1. Previously 1, you get 0. That will make your table complete. Any doubt, please ask how you got this table. These are the inputs. This is assumption of already existing. It can be 0 or 1. So 0, 0 may you get as it is. For 0, 1, you get 0, irrespective of previous. For 1, 0, you get 1, irrespective of previous. For 1, 1, you get previous complement. So after getting this, let's make your K-map. J, K, Q, N. Okay. So 1, 1, 1, 0. Now you can make one quad here. You can make one quad. Okay. Not quad, pair answer. So this is the K-map for your Qn plus 1. What is Qn plus 1? Equation. It is a J into for this Qn bar plus K bar into Qn. Here it is valid for all inputs. It is irrespective of 0, 0, 0, 1, 1, 0, 1, 1. Any input it is valid. For SR it is valid only for 0, 0, 0, 1, 1, 0, not for 1, 1. It is here, it is valid for any characteristic equation we call. What is its name? Characteristic equation. Okay. So next. What is the next one we discuss? Excitation table. So how to make excitation table is reverse. Please remember 2 points here. Yes, you should remember, Sumit. Please remember here 1 point. In the JK flip-flop truth table, if present and next are same, your input should be 0, 0. If present and next are different, your input should be 1, 1. Keep that in your mind. Keep that in your mind. Similarly, if you want 0, your input can be 0, 1. If you want 1, your input can be 1, 0. Like that, you should keep it in your mind. So, is it same or different? Present and next. Presently, you have this. Next, you want this. Are they same or different? Same. Same means you should give 0 and 0. So two possibilities are there to get this condition 0, 1 and 0, 0. Both of them, J must be compulsory 0. K can be anything, whether it is 1 or 0 doesn't matter. Isliye you can take it as don't care. So you observe that condition can be proved here also. It will occur 2 times in your table. It is for 0, 0, 0, 1. It is 0, 0, 0, 1. First J must be 0. K must be either 0 or 1. You observe this? Yes or no? It can be done from the directly characteristic table in the reverse way. If you write, your job is done easily. Next. Present 0 next 1 is required. Whenever you want 1 in the output, you should give input may 1, 0. When will you get 1 in the output? When you give 1, 0. Next. Is it same or different? What is the relation between present and next here? They are different. Toggle condition 0 bar is 1. So toggle condition can be done with 1, 1. So here 2 possibilities. J must be 1. K can be 0 or 1. So you can write it as a term. Again, Qn plus 1 and JK. Present 1, next 0. Whenever you want 0, you should give the input 0, 1. Whenever you want the input, you should give 0, 1. And are they different or same? Are they different or same? Different means you can give 1 1. So this can be anything, this must be 1. Lastly, 1 1. 1 1 means you should, whenever you want 1 in the output, you can give 1 0. And another case is both are same. Both are same means you can give 0 0 also. What is the meaning of both are same, sir? Present I have 1. Next I want 1. I want to change my output from 1 to another 1. Then what is the inputs to be given? If 1 to 1, no need to give anything. Give it 0 0 also, it will work. So for that you can say it is a cross 0. So now you make it in the tabular form. Qn 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 plus 1 J and K. Okay, present 0, next 0, like this. You can see it is 0 cross, 1 cross, cross 1, cross. Okay, so here also our old rule is valid. Remember, yesterday class I told not to remember easily. To cross check 0 1 cross cross. Reverse you read same. Just to remember. Done. So that will give you the analysis of the JK flip flop. Now some people are having this doubt in your mind. What is the doubt you are having, sir? How toggle is advantageous, output is unstable, all those questions you have asked. So now this is the time to answer those questions with the help of an extra analysis we need to do here. So firstly, you understand all the analysis of the JK flip flop, yes or no? Okay, very good, very good. So now I will start. The next one we are going to talk is switching times of flip-flop. Just read them, I will explain. Meanwhile, I will draw some figures. So please go through it. Just give a reading, I will explain. Okay, so let's start understanding this timing diagram, or what we call switching times of the flip flop. So the first one is um, okay. Listen here. The first one is setup time. It is this topic is very important. 2020 gate one question came. I'm discussing this from long time till now. Setup time mein no question came, but 2020 they came. Why I'm discussing this from long time? Because it is important with respect to design. When you go to interviews, etc., also they will ask you in the VLSA. So setup time is the minimum time for which the input must be maintained constant before applying clock. Please understand here. Suppose you see this is your clock. These are your inputs J and K. What I am saying is for setup time, before giving this clock itself, your input should be made ready. Input should be tayar karna. Your input should be getting ready. Then you should apply the clock. Because internal capacitance requires some time to charge or read these inputs. So because of that condition, before applying the clock, according to the system available, it is the minimum time required for which the input must be maintained constant before applying clock. Before giving this clock itself, the minimum time you should be ready is called as setup time. So your exam is at 10 o'clock. You may be allowed into the room and by 9:55 something like that. Your clock is coming here, but your input should come little early than your clock. This is what we call setup. Setup is to set up the system to make your input ready to read the input. And after applying clock also, you should not remove the input immediately. You should keep it for minimum amount of time called as hold time. It is the minimum time for which the input must be maintained constant after applying clock. Here everything is with respect to clock only we speak. This also with respect to clock, this also with respect to clock. There is one more thing. What is that? Propagation delay. What is propagation delay? It is the time required to get a valid output. It is the time required to get a valid output after applying the input. You applied input, say for example, you got the same output, but after this much amount of time. Your propagation delay is not here to here. For gates, generally what you calculate as a propagation delay, input to output time. But here we should calculate from clock to output. Input can be anything, it doesn't matter. Anshu? Not constant. Valid output means for this input, what is the required output that should come. It may be 1, it can be 0, it can be anything. Whatever required for you, that should come. According to truth table, whatever you are having in the valid output, that should come. That is the meaning of valid output. It need not be magnet. It depends. It depends. Okay, you should keep the input from here to here. From where to where? From input to, that is T setup and T hold you should maintain. Your input should be maintained for T setup and T hold. Okay, so please listen here. One thing I want to explain here is, sir, T hold, why not up to next change? No, need not be. Here the output and hold are not having any relation. Hold is for reading the system or to avoid unstable states in between. That you will understand when we discuss the edge triggering and all, that I will discuss later. Hold is to avoid this, what we call changing of the system in one single clock multiple times. That we discuss it. Don't worry about it. For timing, understand the definition. It is the time for which the input should be maintained constant. Okay, everybody see here how you calculate the propagation delay is between this to this. That is after applying clock, how much time is required to get the output. It is not, see here I am again saying hold is not related to output. Whether it is output is coming or output may come late also. Before coming the output also, hold may be removed. There is no relation for that. Hold is depending on the circuit input. Please listen here. You are giving the input here. Okay. That input will affect the system little late maybe. You can remove it before itself. Okay. So hold is to avoid unnecessary feedbacks or unnecessary, suppose some toggle conditions may come here that may disturb the system. To avoid those conditions, hold is required. So don't relate hold and output. So it is the time, generally you can say it is the time required, okay, to maintain the input constant so that it will avoid meta stability. Meta means unstable states or hazards to be eliminated. Simple way to say this is hold time is used to avoid hazards. To avoid hazards and all, we use this hold time. Okay, so now everybody see here one important, wherever you need to concentrate, that point you concentrate properly. Once you apply the input to get the output, how much time you require is setup time plus propagation delay. Until this hold may be less than this TPD or more than this TPD, don't worry about it. Okay, originally these two are important in exam also. These two will play a major role. TPD may be more compared to hold. Okay, in general it may be more only. Okay, so these two play a very important role. In general, we select the time period of the clock greater than T setup plus TPD. That is, you can apply next clock after first you apply the input. Okay, and then what is the time you should wait to get the output? Once you can say like this. Okay, that is, once you apply the clock, you wait until you get the output. Then you should wait to read the next input. Then you can apply the clock. So this is important relation, which we discuss it again later. For time being, I have given this. We will prove these conditions later. So now listen here. One important condition. Race around condition. If input and clock applied, you should not apply. That's what I'm saying. Na? You should not apply input and clock same time. You should apply the input priorly. Just wait for some time. Just forget about it. Just wait some time. Now concentrate here. I will come back to that. Race around condition. Race around condition. What is race around condition? In JK flip-flop, when J equal to 1, K equal to 1, okay, what happens? Assume JK flip-flop, J equal to 1, K equal to 1. Yes, you know toggling. Okay. So this is your input. Sorry, input is already fixed. Na? So 1 minute. This is your clock. And what is this one? We call pulse width of the clock. Its name is TPW. Okay, it is the width on time of your clock and total time period of the clock. You can say simply like that. Put Q. Okay, so once you apply the clock, how much already you assume already inputs are constant, it is applied long back. Assume inputs are applied long back, more than setup time. Now clock is applied. Now once you apply clock, how much time it is required to get the output? Very good. Once you apply the clock, after TPD, you will get the output. Very good, very good. So how much time is required is given by TPD. So after TPD, it has become 1. By the time it is becoming 1, still your clock is present. So still your clock is present. Then what happens? Tell me. It will again toggle after another TPD. So for every TPD, it will keep on toggling like this until your this point. Once clock becomes 0, it will stop. Once clock becomes 0, it will stop toggling. This is what we call race condition. Okay. No, it is not 0. By the time it is becoming 0, still clock 1 na. So again it will change to 1. You see here, up to this point, it will start. It will change later. By the time it is changing, it will check. Input is fixed, man. Abhinay, input is fixed. System don't know whether you are waiting for setup time and all those things. When you change the input, you should apply that input little more than setup time. That is the meaning. Your input is already present. It is constant for a long time here. Please understand. Why it may be 0, Roshi? Please understand. It is becoming 0 now. By the time it is becoming 0, still clock is 1. So it will toggle again. Okay. So, but when clock 0, it will not change. It will, once clock is 0, but one time it will change here. Once it has changed now, clock 0, no more toggle is possible. During this period, no more toggle is possible. But here, as so many people starting itself opposed, it is not a desirable case. Sir, multiple times why it is changing, sir? One time only I want change. Like this, if it change, I don't like it, sir. This is what you said, right? This is unstable, something story you told me, right? Yes, this is to be avoided. Okay, so this case will occur if TPD is less than pulse width. This pulse width is there now. If it is more compared to TPD, then only it will work. Okay, please don't comment up to some time. Okay, listen here. When clock is 0, Q can be anything. It depends on its previous value. Here I assumed its previous value as 0. That's all. Clock is 0 here. It is not 0 or 1. It will continue in the previous value. Here what I did, it is in the toggling mode now. So by the time it is becoming 0, still clock 1. So it will toggle again. Once it toggled, it will stop. It may stop at 1 or 0, doesn't matter. So now listen here. Another case, this is one way to analyze. I am analyzing another way also. Listen, everybody. I have more propagation delay. This much propagation delay is there. So you applied clock here, but I have this much propagation delay. I toggle this time. What is that? I have this much delay. You applied input here itself, clock here itself, but my change will occur here. This is my TPD. TPD ज़्यादा किया. TPD is more. Then what happens? It changes. But now by the time it is changing, what is your clock now? Comment. 0. If it is 0, it cannot change further. It will continue. This is the condition if TPD is greater than TPW, but this change should not occur in the next clock pulse. It should occur in the same clock pulse. So less than time period of the clock. Here, if this condition is satisfied, you can say no race condition. But in this case, you can say there is a race condition. Up to this clear? Now your problem got clarified. If it is not less than time period of the clock, Aditya, what happens? This change will occur after so much of time here. My input is applied in this clock. I expect my output in the same clock or next clock. I want same clock. Everybody is having this misconception. Everybody, please see one thing. Sir, when clock 0, how it is changing? This here also clock 0, how it is changing? This misconception remove from your mind. I am telling you, please see here. During clock 1, you applied the input. That change happens lately. Okay. You see, simple gate is there. Gate is there, for example. You applied 1. 10 nanoseconds is the delay. 1 will become 1 into 1, 1. Say, for example, at 10 nanoseconds, you made it, or at 5 nanoseconds, you made it 0. Then 0 into 0 will become what? 0. It doesn't mean when you make 5, immediately will it become 0. Yes, same thing happens here also. Okay, you observe here, you take a gate of 10 nanoseconds delay. So, suppose your input is like this. You made it at time t equal to 0. But this G1, 1 into 1 is 1. It is like a buffer only. But you get this at how much? 10 nanoseconds. You should not ask me, sir, when input is 0, how your output is 1, sir? There is no triggering concept at all. Okay. You tell me here, when input is 0, sir, how output is 1, sir, here? Same rule here also. You applied clock. As long as clock is equal to 1, it will read the inputs, but your inputs are fixed. Here your inputs are fixed. What are the inputs? It is 1, 1. As long as clock is 1, it will read the input and the feedback also. But because it is not changed during this period, you don't get any feedback. Here it changes only after TPD. But by the time it is changing, already clock has become 0. So don't take the wrong analysis of because it is 0, sir, it will not change anytime, sir. In my lifetime, it will not change, sir. No. Here also same. By the time it is becoming 0, na, still clock is there. Okay, again toggle. By the time it is toggling, no clock is there. I cannot change further. Still you have doubt, ask me. Aman, your doubt is cleared? Very good. This you should get this here itself, but the delays, because of delay, it is coming late. Lazy fellow. Delay doesn't worry about clock. Delay is, say for example, this delay is 6 nanoseconds. Your clock is 5 nanoseconds. You apply input here, it will come at 6 nanoseconds. Whether by that time if clock is 0 or not, you don't know. Na? Yes, but it will change again. If you apply new input, it will again change it. What is the problem? Yes. In the second case, it toggle only once in one clock. First case, it toggles multiple times in one clock. How many times, no one knows. Depends on the propagation delay. This is to be avoided. This is okay. This is okay for me. Okay, Ganesh, ask me what we are discussing only. Don't ask with your prior knowledge or previous things. Okay, we are not talking about triggering at all here. Why are you worrying about triggering registers, counters, and all those things? Up to this, whatever I discuss, you ask that part. Yeah, in the next clock pulse from here, if your inputs are already ready now, after another TPD, it will again change it. Aditya. So for everybody, it is clear. I can move further. Okay, done. Now, Aman, you apply the input today. You want the output in the same day or next day? Tell me, Pierre. Aman, you apply the input today. You want the output in the same day or for the next day? Our job is for one clock, one output. Okay, for one clock, one output is my desirable thing. So when I apply the clock, before applying the next clock pulse, my output should be ready. I should not get this output in the next clock pulse or tomorrow. Very good. So now please listen. I am writing or concluding this in JK flip-flop. When J equal to 1, K equal to 1, clock equal to 1, I am assuming, okay, J equal to 1, K equal to 1, clock equal to 1. If the propagation delay of the clock is less than pulse width of the clock, that is, flip-flop propagation delay is less than pulse width, then output may toggle more than once in a single clock. We call it as, very good, race around condition. Everybody understood this race around condition now? Right. Next. To avoid race condition, what to do? Now we are coming to the point, first point. Your TPD must be greater than TPW, less than time period of the clock. But here, wait, listen here. So I should not increase TPD. It is not suggestible. Propagation delay should be as minimum as possible because we have very less patience. We want our systems to be working immediately, not lately. So I don't compromise on my speed. I don't want to increase TPD. TPD is a delay. Delay should not be increased. Delay should be decreased, but should not be increased. Then what to do is reduce TPW. Reduce TPW, that is width ko kam karna. You should compress the width you reduce, almost make it equal to 0. If you are able to make it equal to 0, that is what we call edge triggering. To make the width almost equal to 0, not exactly 0 is not possible. Okay, almost equal to 0, then we get one flip-flop called edge triggered flip. Now I will explain what is triggering and all those things. Okay, so because unless its need comes, without that if I explain it, it will not be having much meaning. That's why I have not explained what is triggering and all earlier. Now you understand its need or its necessity. Now, thank you, Krishna. Now the next one we are going to discuss that based on this is master slave JK flip-flop. What is master slave also we will be discussing. Okay, so this first part is done. Now we'll move to the second and third parts. What is edge triggering, what is level triggering, everything we'll discuss. Thank you. So now 1 minute. Thank you, Abhijit. 1 minute. Aman, you have doubt in this slide, ask me. Now it is clear. Very good. Then one more thing. You observe here, I don't take clock in this way. I take clock like this only. What is master slave? I have not discussed, Chaitanya. I will discuss it. I told we will be discussing next. Okay, master slave is not discussed, just we will be discussing soon. Okay. Thank you. Now listen 1 minute, 1 minute. See here. Why I have not taken clock like this? Why I took a clock like this? Generally, originally clock is like this only. It will have some rise time, little maybe rise time will be there now. So to calculate this also into consideration, we generally take this middle point as the reference. What is that? 50% level is the reference while calculating delays in your VLSI systems or the digital systems. Okay, so 50% level from here to here they will measure the difference. Then they will say what is the propagation delay and all those things. So what is the reference point they will take is a 50% level. Why not they take 0 to 0, sir? You may have this doubt. Sir, 50 to 50 and 0 to 0 both are same. Why can't you take from here to here? Even it is non-ideal, this gap is same na. You just assume, you just tell me. No, 0 to 0 or why not 1 to 1? Why 50%? Or you take 1 year. If 0 is not easy for you people, maybe it is 0 from long time. Okay, you said. If rise time is different, 50% also different now. One thing you see this is changing from 0 to 1. This is changing from 1 to 0. You should not take these two as the delay. Okay, this is changing from 1 to 2. It is changing from 3 to 4. What is the delay? You should count from 2 to 4 or 1 to 3. Okay, the moment it has your input is changed and your output is changed. That's why to avoid this confusion, if you take from middle to middle, no problem at all. It will consider your rise time, everything will be considered. Okay, you should not take it from here to here. In this case, both are changing from 0 to 1. Suppose one is changing from 0 to 1, one is changing from 1 to 0. It will not give you proper analysis. So let's go. Still you have individual doubt, don't worry. At the end of the class, we'll come back. So now first point is cleared. So Chaitanya, we have not discussed anything about these two. Now we are coming to the second point, edge triggering. What is that edge triggering? Reducing the width of the pulse to make it almost equal to 0 is called as edge triggered JK flip-flop. Okay. So let's do that. Okay, just wait 1 minute. I want to take one slide. It is that. 1 minute, please. Not paused, just wait. I'm taking one slide. Actually, I forgot to take this part. Yes, that's it. What happens? I am not able to make the slides today because of I have two classes, and one thing is no power. Just before starting our class, after starting class only we got. Okay, listen here. Right deep. So let's see the basics of the triggering. What is triggering? Let's understand. Okay. So now listen. Triggering is basically classified into two types: level triggering, edge triggering. In the level triggering, we have positive level and also negative level. Two types of level triggerings are there. Similarly, here, positive edge triggering and negative edge triggering. If it is level in the level triggering, what is the condition in the level triggering? Based on the type of triggering, observe here. Output changes during one level of the clock and remains constant in the previous state for the remaining period of the clock. Okay, please understand. This is what we discussed till now. Yes or no? For example, positive level triggering. Okay, output changes according to input. Okay, when clock equal to 1, comma, output is equal to no change when clock equal to 0. You accept this or not? We discussed this till now. We discussed only this part. Positive level triggering, what is that? Please comment. Output changes according to the input as long as clock is equal to 1. When clock becomes 0, it will not change. Okay. Similarly, you have another case similar to level triggering. What is the other thing you have is edge triggering. In the edge triggering, output changes according to the input only during any one of clock transition. What is the meaning of clock transition, sir? See, clock changing na during this time. Maybe from 0 to 1 time or 1 to 0 time, but not in between. So if you design like that, it will change only when clock is changing from 0 to 1. In this time, it will be in the no change condition. It will not change in both the cases. It will change in any one of this, either when clock changing from 0 to 1 or either when clock changing from 1 to 0. This will occur only once in one clock pulse. Na? So what is the advantage of this? Tell me. It remains in the previous state from the yes. Let me write during the other period. For example, in positive edge triggering, output changes according to input when clock changes from 0 to 1 and output is equal to no change. Okay, what is multiple triggering, Aditya? Otherwise. Okay, yeah. In this case, because positive triggering you take, for example, positive edge will occur only once in the clock. So in between, even clock may be 1 or not, system will be disabled. We design like that. I will show you how to make the design like that. So in between, this fellow will not work. Is it okay? So now you can say in level triggering, output can change for more than once in one clock. Output can change more than once in one clock. But in edge triggering, it is not for JK, it can be for any flip flop. In edge triggering, output changes only once in one clock. Okay, so here there is no race condition. How to make that we see. First understand that. Yeah, in the negative. Just wait. I will give all those things. Just wait for Ritik. So now is this 2 points clear? The level triggering output changes only for more than once in one clock pulse. Can change in the edge triggering output changes only once in one clock pulse. Now listen. Let's assume this is your. So this is the symbol used for the clock. Here it may be any flip flop. It is JK or SR. Don't worry about it. This is for positive level triggering. This is for negative level triggering. Okay. So what is the meaning of it? Let me explain with the help of figure. Okay. So during this period, if you assume this as your clock, level triggering I am saying, during this period, output can change based on input, depending on input. But during this period, when clock is 0, it is in no change condition. Clock 0, it is not 0, it is no change. Similarly, you can have one inverter for the clock, then okay. Now what happens? Now what happens? Here, no change. Here, green signal. Output can change. This is just a reverse analysis of this one. This is what we call positive level, negative level triggering. Is it okay? Right. Just 1 minute. Just 1 minute. Just for fun, Sushil. Whether eraser is working or not, I'm checking. Sushil, you don't like, then I will get back this part. Okay. So now, listen. So now we are discussing positive edge triggering and negative edge triggering. Okay. So this is the symbol. You will be having sharp triangle here. In the positive edge triggering, when clock changing from 0 to 1, output can change depending on the input. But for the remaining period, whatever you have, it will be in the no change condition. Similarly here, so that eraser helped to save so much time now, you understand? Okay. So when clock is changing from 1 to 0 during this period, your output may change. So like COVID restriction, you are able to go out only during this period. Remaining time, stay home. Same here. System is restricted to change. If you want to change, you can change. If you don't change, I don't allow in this time. I didn't change it, sir. I don't read my input. Shall I read it now? No. Is it okay? Yes. So it will read the input only during the edge. That may come little delay, no problem. But it will read only during the edge. It can be at 0 to 1 or it can be 1 to 0. Positive edge is also called raising edge. Okay, negative edge is also called falling edge. Yes, only once, one clock. One clock may one time. Early now in your advanced process, what they are doing is they are using both. Here also they are trying, here also they are trying to synchronize the system or to improve the speed. They call it as a turbo speed, so that they are able to make your processor to work faster than their designed speed. What is the processor speed is generally decided by whom? You purchase processor na microprocessor 1 GHz, 2 GHz processors at your home. That is decided by this clock only. System clock. System clock will decide that. Okay, right. So you cannot purchase any very good clock and make your processor to work fast. That is decided based on the internal design like this. Right. So now let's go further. It is now clear na edge triggering is completed. That is, sir, what is the maximum speed of the processor? It depends on the processor, man. Maximum speed means generally processor speed is given by 1 by frequency of the clock will give you T state. T state means time period. So for a given job, how many T states it requires? That will tell you how much time system will take. Now present days it is going on gigahertz, right? Yes, new technology is some 2.1 gigahertz, something it is running like that. Yeah, that is your VLSI layer, thickness of the layer, your wafer thickness. MOSFET that you study in the analog. So where we are, right? Let's move further. 135 nanometer, etc. Okay. So please listen. Two things are done. What are they? This is done. Now this is also done. Now one fellow is left. Who is that friend? Master slave. This is very good friend. So let's explain. Let me explain you what is the meaning of master slave. Are you ready? Okay. But before that, let me give you little basics about this edge triggering internal circuit. Sir, how blindly we can say it is working only for edge? Will you make some mantra here so that it will work only at the edge? No. How to make the design of the edge triggering? Let me show you. Say for example, see here. You have original clock. What is that? Bashkara. Now I apply this to differentiator. RC differentiator. What is the differentiator? High pass filter. Yeah. Some kind of that circuit. Okay. Now listen here. Yeah, you can do clock bias table. Correct, Alice. Now we use some kind of clipping circuit. You may use negative clipping or positive clipping. Accordingly, you may need this kind of circuit. So you are able to convert what is this positive edges total clock into a simple positive edges. Is it okay? So this kind of circuitry is required to make this. Or another simple way to do this, let me do it. See the beauty of this. This is having some very little propagation delay. If you apply this input, what happens? Let me take A bar, and Y. Now you see it is A. Say for example, this is your clock. Okay, this is the clock. Say A. Now what is A bar with little delay? After TPD, your 1 will become 0. After TPD, your 0 will become 1. After TPD only. This is just having some delay. Kitna delay is there? How much delay is there? TPD. So it is your desired output will come after TPD. Now listen here. What is your output? Y is multiplication of these two. What is the multiplication of these two? You tell me here. It is a 0, and for some time you are getting this one. Okay. So what is this circuit? It is called as positive edge detector. Everybody okay or not? Every time clock positive edge comes, it will give a small duration pulse in the output. Yes, correct. So for every for every clock, during the positive edge, you get small pulse. Fine. Okay. So this is what we call edge detector circuit. You can make some delays using the delays of the gate. And gate may be delayed, that may be shifted, that doesn't matter. So this is one kind of. Similarly, can you design? I'm giving you small homework. Negative edge detector. You may use NAND gate, NOR gate. It is up to you. Try. Try this. Frequency is same, man. Deep. From here to here is one clock. Here also same, na. During this time, you are not getting any one. Only one is coming at the positive edge only. Same frequency, but reduced with will come. Okay, I want to upload one figure. Just wait. Let me upload one question. Okay, so here my question is, I'm making one question on this one. So let me make the names X, Y, Z. Okay, don't worry about these bubbles. It will not make you much uh, difference. Okay, this bubbled OR gate is nothing but NAND gate. You know it already. So now what I want to say is, in the okay, which of the following can be called option A X, B Y, option C Z, option D none. So go back, see the figure. I will start the poll. That I need not say. I should not say until end of the question. I won't say. Suppose this question comes in your exam. Suppose you know flip flops already earlier before our class itself. So you will be able to answer or not. Let us see. Right? Pulse steering. Pulse ka direct karega. Aisa you can think like that. I'm not saying that. That is correct. Okay. So you see here edge detector means already you know what is edge detector. This is your edge detector circuit. Okay, just now we discussed na in this part or this part or this part, whichever is called as pulse steering circuit. That is the question. So let me start the poll. If you don't know, just make it none. Ready? Just your common sense. If you test, you will be able to answer. Or your guesswork may also work sometimes. Your luck. Try your luck in the worst case. Genuine people are 2%. Singh, Kumari, Himasri, Hrutik, Kadali, Vasista, Deep, Anuj. Who is that? Sadbhavana, Anupama, Asif. So what is the right answer is Y. Why is your doubt? Why? Okay, for example, if S equal to 1, okay, you have clock here. S and C equal to 0. Okay, then what happens? You have clock here. Tell me, 1 into anything, 1 into clock. What is the answer here? Clock bar. Okay, so 0 into anything is 0, whole bar is 1. Let me tell you here also. When S equal to 0, C equal to 1. Earlier what I did, right? So now here also clock is there. Clock in 0 into anything is 0, whole bar is clock into something is clock bar. Okay, so that's why we call, I know you are not convinced until I explain the logic again, the second part as pulse steering circuit. Listen, okay, these two NAND gates will steer your clock to the top or bottom. Okay, this pulse is there now. This pulse may be sent to the top, or sorry, may be sent to the top or bottom. Top or bottom, you observe. Okay, and both zero, you don't need clock now. No change condition and all. Okay, you understand? Set and reset, set and clear condition. You need the clock when for 0, 1 and 1, 0 only. For 0, 0, it is a no change condition. Okay, so you understand? Justified with the name, this part is called as a pulse steering circuit of your flip-flop. Okay, next, one more thing. What to do? What is the time? 10 minutes. I don't want to discuss master slave today. I will discuss tomorrow. Those invalid and all, everything same, man. Okay, don't worry about that. Set and reset me, what happens? I want to speak that part only. So let me give you a small concept and end the class. Tomorrow we discuss happily that master slave. Because I want minimum half an hour to explain that master slave. Okay. So let me upload one extra concept. Today is one more class. What is that? Oh, आपको class भी है. Okay, no problem. I will leave. Just 5 minutes I will leave. Which class? 11 p.m. to 12:30. Oh, is it a special class? Morning class is cancelled or what? Okay, shifted. Okay, no problem. Okay. So get ready with your chai and biscuit. You should be ready with flask of milk and all, right? Coffee. Okay. So, right. Today's last concept. In JK flip-flop, when J equal to 1, K equal to 1, clock equal to 1, what is Qn plus 1? Toggle Qn bar. Yes or no? Now please listen. This is your clock. What is your output? Assume positive edge triggering. Assume positive edge triggering. What happens? During the first clock pulse, this 0 you assume initially becomes 1. Second clock pulse, it will become again 0. For third clock pulse, it becomes 1. And this story repeats. Everybody accept this or not? Only one change in one clock pulse. At the edge, assume no delay and all those things. At the edge, it will change. Only at the edge, it will change. Okay. Now, if you take this as time period, what is this one? Very good. So if you take this as a t, this t not equal to 2t, or your frequency f not equal to f by 2. This is what we call frequency divider circuit. Yesterday class, I told this already. Flip-flop can be used as a frequency divider circuit. So you see the advantage of toggling condition. During the toggling condition, it will work like a frequency divider circuit. Q and Q bar, you get Q bar, you take 180 degrees phase shift will also come. Symmetrically 180 degrees phase shift, two signals will come. Yeah, you take one more flip-flop, you can divide by 4. You take another flip-flop, you will divide by 8. Output of 1, you connect to another output. No, if you write Q bar also, your signal will be like this now. These two signals are 180 degrees phase shift because they are having half time period difference. Divide by 3 is by using counters you can do mod 3 counter. Q bar same as Q with 180 degree phase shift. Will you accept this? You have this signal as a Q. What is your Q bar? Half time period difference now. Q. Okay. So I told this earlier in the flip-flop can be used as a frequency divider circuit other than memory. Now you see this one. This is very good, very good. Please observe here carefully. Suppose you are pressing your keyboard switches. Earlier mechanical keyboards are there, right? You use it to press the keys, typewriting, etc. You remember? If you press the key or you move the switch from this position to this position, it is ground, this is 5 volts. Now what is the input coming to the resistor is when you move the mechanical switch like this, it will vibrate for some time, yes or no, oscillate for some time and settle down. So during that position it will bounce like this and come to settle state. This is called bouncing. Now what I will do is I use one flip-flop, okay, one latch. Okay, it can be any latch. In this example, it is a NAND latch, not usable. Right. So I took NAND latch because it is active low. Bubble is shown means it is active low. I told already this yesterday, right? So now you observe NAND latch. What is 1 1? Tell me what is 1 1 NAND latch? No change. Okay, now you observe. It is already in 1 1. You just connect this ground here. What happens? 0. Okay, you connect this ground here or here, it is up to you whether if you connect it initially, you already connected to 5 volts, you connect this switch to this position for example, then 0 comes, it may oscillate as 0 1 0 1 like this, no problem. Why? One input is oscillating as 0 1 0 1 but other input is 1 only, so it will read 0 1. After that even it becomes 1 1, no change na, it will not read. So oscillations will not be coming in your output in this case. This is what we call debouncing circuit. Okay, listen. Little networks knowledge required here, and keep this. See here. Originally, suppose if it is not flip-flop, if latch is not there, what happens when I move? Whether this ground, first assume these two are 5 volts. That means already you have here 1 and 1. Now I am connecting ground either here or here. Suppose I connect here ground, then it becomes 0. But because of switching transients or because of these oscillations, damping oscillations, it will not become 1 directly. Sorry, it will not become 0 directly. What happens? One line is already 1. Other line touches and leave, finally it settles at 1. Sorry, finally it settles at 0. I am repeating, please listen. One line is at 5 volts. Okay. Other is connected. Other is initially this much. But I change the switch to the position of ground. It is because of the connection, sometimes it oscillates, and because you press the key like this, okay, with all your anger, then it will oscillate, finally settle down. Okay, so during this oscillatory period, I should avoid reading the input. That's what I want to say. That can be done here because during this period, it is anyway no change. You understand? You see the figure. This is the advantage. It can be used in key debouncing circuit. It is a basic debouncing circuit. You understand? When you move the switch, switching transients will not be affecting your output. Even it is a 0 or 1, it will read same. It can be, you may connect it here or here, it is up to your requirement. You may read 0, 1 or 1, 0 accordingly. You don't connect the switch both the cases. So that's all for today. You understand the practical utilities, two utilities here? Yeah, you can post, Tarun, if it is a small doubt. If it is a big doubt, you can ask me in the doubt session then also. Thank you. Good night. So these two things are clear. Tomorrow we start with this part. We do more, at least around 50 questions we'll do from the sequential circuit. So don't worry about the number of problems. I want to give you proper basics in the theory first. Good night. Good night. Differentiator is nothing but you apply at the edges, you get the output like this. Negative edge, you get negative output. Positive edge, you get the positive output. When your output is changing from 0 to 1 or 1 to 0, it will reflect in your output. RC differentiator. This is the circuit which will give you this kind of output when you apply constant, because when it is changing from 0 to 1, it will give you positive spike. When it is changing from 1 to 0, according to the slope, you get the negative. Sir, in pulse steering circuit, what happens? If it is 1, 1, it is invalid case. Why are you worrying about invalid case? SR flip-flop, it is SR flip-flop. Right? 1, 1 is invalid. You need not worry about it. Thank you. Good night. That is that Mux question someone asked me. Transients are ignored because, see here, suppose you are connecting this input to here or here, you assume anywhere. What is the doubt in differentiation? Sushil, what is the differentiation of this signal? Here it is changing from 0 to 1, now you get slope, d by dt not 0. Remaining period it is constant, d by dt is 0. Again slope is there, d by dt non-zero. D by dt non-zero. Swapnil, see here. You tell me, you are ready, Swapnil? Here by default both are at once. By default 5 volts are connected now, both are ones. For both are ones, no change. For the NAND latch. By default both will be 1, it will be no change. If you connect some ground to any one of this input, I am connecting to the second input, then what happens? that ground may commit as 0 and the other will be at 1 only. So 0, 1 will give corresponding output in the output. Because active low, you may get 1. Okay. By chance, if this is having some loose connection, if it becomes 1 also, no problem. Once you give the input 0, it will give you output set. After that, because of transient, this has toggled for some time, no problem for me. It becomes 0, 1 anyway, because 1, 1 also give me same output. It will not change for 1, 1. Is it clear, Swapnil? Earlier case, for 1, 1, you are getting disturbance in the output because of between this kind of circuit. Here, see, if you connect here, switch is toggling, then your output will also toggle. What is your question? Count f of something is there using the mux. Okay. Why can't we do like this? Yeah, you can do. What is the problem? All ones, this is 0 na, C bar plus D. C bar plus D bar, correct. Both are correct. D, nothing, C D bar. It is correct only, but what is the required condition? What are your selection inputs? That is important. You can happily do, but here, what are your selection input is EAB. That's all. What is the problem? You can do happily. If you take it like this, EAB are the selection input. If you take in the rows, CD are the selection input. That's the difference. What is the variable here is AB. So AB are the selection input. What is your doubt, Tarun? You can do it happily. Because in the question, it is given same selection lines. I have taken same selection line. I never said that you should take the same selection lines. I have given you A, B, B, C, C, A, all possible selection lines and also done the problem. Yes, cell number will change. If you want min terms, it will not be same. Okay. If your A is MSB, then it will be different. If cell numbers will change, definitely changes. Expression will not change, but your min terms will be changed. If AB is your MSB, accordingly min terms will change. If it is 0, 0, it is 0. 1, this is the min term, and this is the min term. These are the min term boxes. If min terms are asked, definitely you should read ABCD. If you take here ABCD, it is 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 1, 3, 2. According to your direction, if you assume A, B, C, D, this as MSB, this as LSB. Accordingly, your directions will change, definitely. Okay, if you are making the min terms here, maybe he did wrong also. If A is MSB, yeah, 0, 1, 0, 0 is 4 taken. No. Cell number written wrong, Swapnil. Process is correct. Who is that? Tarun. Process is correct, but cell numbers are wrong. Okay, if you want to take, you take like this. Then you should mark it, then that will give you the inputs. Is there or not? You are there or not, Tarun? Is it clear or your doubt? Okay, done. So, bye bye. Good night. We'll meet tomorrow. Good night all.